Hello, this is one of the HL7 FHIR videos, and this particular video focuses on the search API. My name is Terry Sippel-Schmidt, and we're going to jump right in. These are the learning objectives for this video. We're going to spend a lot of time discussing name-value pairs for search parameters. We're going to discuss where to find the search parameter names. We're going to talk about some of the modifiers which apply to search parameter names. We're also going to look extensively at the values, specifically the data types and how to encode them, and also prefixes that apply to these values. Let's go through some of the basics. You've seen this diagram already where we have all sorts of clients out here, whether they're a tablet or a very expensive medical imaging equipment. And over here we have a server, whether this is a FHIR database or whether it's a FHIR interface engine. And perhaps there's an EMR or a cardiology or radiology departmental system here that you're not going to forklift and get rid of, but there's proprietary interface in between these two so that you can expose an international standardized API so that all of these clients can access the server in the same way. We've discussed for persistent storage the acronym CRUDS, which is create, read, update, hopefully it's deprecate and not delete, and S. S is for search. FHIR defines search API formats and data value types at this URL. There's a very long web page in the standard which discusses just all the different search parameters. In terms of finding out what the search parameter names are, however, you go to each resource. Each resource has a different set of search parameter names, which makes sense if you think about it, because you're not going to look for the patient name in a provider or observation or care plan resource. You're going to look for it in a patient resource. So you're going to go to each particular resource web page and scroll to the bottom where you will find search parameters. On that search parameters page, there's several different lists, but the two that we're going to focus on initially are the name column and the type column. This name column is the name of the search parameter that you can use, and this type column is how you format the data which you include in your name value pair. All right, as I mentioned, all the information for the international standard is located at this HTML page, which is part of the standard. Personally, I think it's a bit of a difficult read. There's also additional information on searches as part of the Happy server documentation, which it's easiest just to type it into Google or a search engine, but you can find the search page for the Happy documentation. I think this might be a little easier to read personally, but remember that this is server dependent and this is the international standard. Now, we're going to hit a pause screen in just a second, but you're going to open up several different resource tabs on a browser window and keep them organized. You're going to scroll down on two of them down to the search parameters. This is going to enable you to compare to the standard as we go along. So pause this video in just a minute, but in the end, you should have 4 tabs going across, 2 being patient and 2 being observation. The first one for the patient is going to be the resource, the structured content, and it'll look like this. For the second tab here, you're going to scroll down to the very bottom, in this case, section 8.1.12, and it's going to look like this, and then do the same thing for observation. So go ahead and hit pause now, please. All right, let's discuss the base API syntax quickly. So FHIR uses the get syntax in 2 different places, both a read and a search. Here's the difference. In a read, the HTTP verb is get, and you've got your base, your URL. In this case, it'll be the FHIR server. The type is which resource you want to go and get. And then for a read, the last piece of information in a FHIR API is the computer identifier, the unique identifier on that server. So you're going to go and get this resource, and you're just going to go and get it because you know exactly where it is, you know what you want, you're going to go and read it. A search is slightly different. A search is also an HTTP get. And you're going to go to the same base URL or to the same FHIR server. And you're again going to ask for the type of resource that you want returned, whether it's a care plan or a provider or an institution or a patient or a report or an observation. But then you're going to say where. So this little question mark symbol is the indicator for the parameter list to follow. So where, and then you're going to have a list of search parameters. And we're going to spend this entire video on this particular section right here. So the search parameter syntax is name equals value. When I look here, I have the parameter name and the parameter value. And where are you going to find these? You're going to go down to the particular, this happens to be observation, and you're going to go down to the search page, and here's the list of names that you can use. here's the list of values which you're going to use for that name. So for example, a search name of code will use a data type of token. If you look on the search page itself, you can find all the different data types for the values. There's actually not as many as you might think. There's number, date or date time, string, token, reference, composite, quantity, URI, and special. And these are the different data types that you can use as part of a FHIR API. In this particular video, we are going to go through the data types of string, date and time, number, quantity, and token. The others will be covered in part 2. Let's get started with string because it's the easiest to understand. So if you go to the patient resource, you can find a search parameter name of family, and it tells you very clearly that the data type for family is a string. So how do you begin to build an API? So we're always going to start by building an API with http://. Here's the server URL. In this case, it's the happyfhir.org, and the path, which tells us to use version 4 or base R4. This next one is always going to be the type of resource that you want returned to you. So in my case, I'm asking for a patient. So often in FHIR, you're looking for a specific patient. And so we're going to build the search parameters using an ampersand or an and sign. So here's the story. We always tell a story because you always base your queries upon a story. Paul Smith is on the phone, and I need to look up his patient record in the system. That's a pretty basic story. Here's http://. Here's our server URL. We're asking for patients where the family name equals Smith and the given name equals Paul. So in this case, this particular query string or search string should return all instances of Paul Smith, of which there may be more than one in the database. But there's more that we can even do with just the name modifiers before adding additional parameters such as date of birth. So FHIR has the concept of name modifiers. And what that means is we can take the name of the name value pair and we can constrain it further. If there's no modifier on the parameter name for a string, so this is specific to a string search, if there's no modifier, the definition of how it does the comparison is using starts with. So for example, if we had used given without any kind of modifier, it's also going to find given is equal to Eve. It's also going to find given is equal to Evelyn. We can do contains. So if you would like to do, for example, anywhere within a string, not just begins with or starts with, then you would use the contains modifier on the name. So now you've got contains Eve, but it's also going to find Severin. Or you can do exact. And exact means that every character has to be exact, including the case. So for example, uppercase EVE is only going to find Eve. Let's talk a bit about date and date time searches. All right, so the value for a date time in FHIR is year, dash, month, dash, day, T for time, hour, colon minutes, colon seconds, and then it actually keeps going. I didn't put everything on here. It goes down to milliseconds. But you don't even need to use all of these. So for example, for a value date, I could have used just the year. I could have used just the year and then the month and the day. So you have to begin here, but you can delete the information going from right to left. All right, another story. I know that the lab sample was taken on December 15th, so only give me lab values on or after December 15th. So here we have HTTP, the URL for the server. We know we want an observation because it's a lab value, where the value date, which you should go and you should find that on your observation window under the search parameters right now. You might want to hit pause, is equal to 2021-12-15. This will find all observations made on that date for any patient. But wait, we can add prefixes to dates, similar to the way that we could add modifiers to names. We can add prefixes to values. So new story. I know that my patient came into ER on December 15th, but I'm not sure if the lab sample was taken immediately or not. So only give me lab values on or after December 15th. So this is a little bit of a strange query, but it will give you all of the lab values for any patient on or after December 15th, but we're going to apply a prefix to the date value. So here we have our server, we have the base R4, again, we're still trying to get observations where the value date is equal to, greater than, or equal to. So this is what's called a prefix, and we can apply this prefix, as I said, to any value, including that of date or date time. And the prefix goes, in this case, before the value. The modifier went after the name, the prefix goes before the value. So what prefixes exist? Excellent question. We have equals to, not equals to, greater than, less than, greater than or equal to, less than or equal to, starts after, which we can also use for date and time, and ends before. We also have approximately, and approximately is an interesting one because not all servers support it, so be a little careful, but approximately is within a range so that especially if you're looking for like lab values, that the data does not have to be exact. FHIR recommends a 10% range, but it's up to the server implementation. All right, these prefixes can apply to data types of dates or date and time, numbers, or quantities. Now let's search for a range using and as well as prefixes. New story. I know that my patient came into ER on December 15th, but not sure if the lab sample was taken immediately or several days after. So only give me lab values on or after December 15th, but before December 19th, because I know that was when they were discharged. All right, so we have the same URL observation where date and time is greater than or equal to December 15th of 2021, and the date and time was less than the 20th of December. So by adding these particular prefixes and putting the ampersand in between, we've now created a date range search. Let's jump into number. Another data type format is number. So here we have a search type where we're looking for a search parameter name called probability, and the response is a number. A number can be an integer, a decimal, it can be positive or negative, and it has to match in up to 3 to 5 digits of precision. So for example, 100 will actually match to 99.5 as well as to 100.5. And this is server dependent, and they should tell you in the server specification exactly what the precision of match is. I'm going to put a caveat on this and saying that a data type of number is actually pretty uncommon. And we're going to work a lot more with data types of quantity, but we're going to keep this in here for the sake of illustration. News story. As part of the population health study, give me all risk assessments which scored high, where high is defined here as greater than 80%. Here's our FHIR server URL. Here's the type of resource that we're requesting, which is called risk assessment resource, where the search parameter name of probability is equal to 80% with a prefix of greater than 80%. Now we could have made this greater than or equal to 80%. Search for a quantity. So you'll see this a lot more often. So here we have, this happens to be part of observation, by the way. Here we have a search parameter name, a value quantity, and we have a data type of quantity. So what's the format for a quantity in FHIR? The format is that the name, here this would be value quantity, the name value quantity is equal to a prefix and a number. And this pipe is a delimiter. And so it's saying this piece of information is separate from this piece of information, which is separate from this piece of information. So the second element in here is a system. So this is your code system, whether it's LINQ or SNOMED. And then the final piece of information after the second delimiter is the code value itself. So let's walk through this line in a bit more detail. The square brackets mean optional, but you need at least one of the three. You can't have it be completely empty. The prefix, this number right here, this prefix, which is optional, is from the table from several slides back. The number, which is here, is defined from the previous slide. So we discussed whether it can be decimal or it can be integer, positive or negative, and precision matching. As I mentioned, this indicator, I happen to turn them red here just so they would stand out a little bit more. This indicator is a pipe, it's a delimiter, it separates the fields. It's very similar as a placeholder to HL7 version 2, if you're familiar with that. The system is a code system as defined as a URL. In observations, you're going to see this a lot, HTTP, unitsofmeasure.org, where units of measure is an NIH project, which stands for Unified Codes for Units of Measure. In other types of resources, you might see this as LINC codes, you might see this as SNOMED or World Health Organization codes. But the important thing to know is that it's defined as a URL, and there's a list of those under terminology on the FHIR webpage. Then the code is usually the code itself. And in this particular case, in an observation, or especially in a quantity, it's going to be a code of a unit of measure. All right, let's do some examples. Let's tell a story. Here we have a quantity value. We're just looking for a quantity value of 8.5. All right, we can do that. That's pretty simple. Our search name, our parameter name is value-quantity equal to 8.5. That's it. We can add a prefix to this. Value quantity is equal to less than 8.5. This is still sloppy coding as far as I'm concerned. I would never do this. This is much better. Value quantity is equal to less than 8.5 using unitsofmeasure.org, and particularly what we're looking for is less than 8.5 milliliters. Okay, let's go into a little bit more detail. Another story. I am looking for lab values which were obtained after March 21st and are higher than or equal to 95 milligrams. So let's go through this again. We've got HTTP, we've got our server, we're looking for observations where the date is greater than March of 2021, and the value quantity is equal to greater than or equal to 95, and the units of measure is milligrams. So you can see that once you get used to putting the structure together, it's really not that hard for the simple queries. So please go ahead and compare these to the search parameters on the observation resource and make sure that you can interpret this API on your own. All right, next data value type is that of token. We're starting to get a little bit more complex here. So a token format is usually used for a coded value or a business identifier. So not an ID, but a business identifier, such as medical record number. The format for a token is name is equal to system, and here's our delimiter again, our pipe, and code. So let's walk through this. The square brackets mean optional, but you can't have everything be optional, so you have to have at least one of those. System is the code system URL or the identifier system URL. So perhaps this is LINC, perhaps this is SNOMED, perhaps this is the system, the URL for the system, which is defining the medical record numbers. Perhaps it's Social Security URL. Again, the pipe is a delimiter or separator between fields, just like HL7 version 2. And the code is the coded value. In this particular example, that looks a lot like a LINC code, or it's an identifier. In this particular example, it looks like a medical record number. Let's build some examples. All right, this is a valid API. Code is equal to, and here we're just using the coded value. So here's the parameter name, code is equal to this number, and that's it from LINC. This is not great coding. I wouldn't do this. This is a better search. Code is equal to, and I mentioned it's the URL, so here's the LINC URL, here's the delimiter, and here's the code. This search right here, if there were to be another code in a different code system with the same value, is going to find those observations as well, not just what you're looking for. So that's kind of sloppy coding. Let's go look at an identifier value. So identifier is equal to this string of digits, and it's just the identifier. I think it's probably a medical record number, but I'm not 100% sure. And I really don't know who assigned it. So if you have multiple places assigning patient identifiers, which can happen when one hospital acquires another hospital system, it happens all the time, you can have patient ID collisions. That's really a bad thing. So let's put the medical record number URL for the assigning authority into the string as well. Identifier is equal to, this is just an example, stjoehealth.org FHIR medical record number assigning authority, and here's our pipe where this particular MRN. Now you're only going to get one patient back, and that's what you want because you definitely don't want to mix results. Remember that codes can either be a code or they could be a codable concept. So let's go take a look at the difference between the two. We're going to look at an observation resource, the structure of an observation resource, and we're just going to show this, we're going to demonstrate this by example. So here you can see The element name within the resource is status, and the data type is code. And here you have an enumerated value set or a value set. You have registered, preliminary, final, amended, and they're telling you it's extensible. Down here, you have an element named code of a data type codable concept. So here you have both an element named code and a data type of code. I will not defend that this isn't confusing, but it's the way it is. So let's keep going. Let's talk a little bit more about this one. And then this one's on the next page. So when you have a data type of code, value for this particular data type is bound to one of these answers over here. So it has to be an answer out of this value set. So as an example, we have status is equal to preliminary. Status is equal to final. It could be something else if you extend it. In general, don't extend it if you can avoid it. Codable is a little bit more difficult and a little bit more complex. A codable concept, if you look it up, go ahead and click on it in your resource, has two different parts. It has a coding part and it has text. The reason it has text is not everything is codable. And so some things will just be in the text element of a codable concept. A text element is just a string. So as an example, we have code is equal to, because remember that this is your search parameter name. So your search parameter name doesn't change. It's just code. Code is equal to diabetes. This is going to search for anything in a database where has been coded as a string diabetes. Coding by string isn't a great idea, and you don't want to do it if you don't have to. So let's look at something a little bit better. Let's look at using a coding system. Now, the format for a coding system is the search parameter name is equal to the system, the delimiter, and the code value. So let's take a look at that. Here we have code, because remember the search parameter name doesn't change. If go ahead and look at that search parameter window under the observation resource and make sure that you can find that. Code is equal to http://loinc.org. Here's your delimiter, and here's your coded value. That's a much better way to implement a coded value. So let's tell a story. I am looking for lab values which were obtained after March 2021, where the total hemoglobin A1C was greater than or equal to 6.5% as an indication for diabetes. So this is casting a more narrow net, and yet it's looking across patients, perhaps looking for any patients who maybe they should be monitoring for diabetes. So let's walk through the query URL. Here we have our server. We're looking for observations where the date is greater than March of 2021. The coded value, so our search parameter here is code. We're looking for LOINC codes, and 4548-4 is the LOINC code itself for A1C. And the value quantity is greater than or equal to 6.5 using, there's your delimiter, the units of measure of a percentage. So this is the query string that you would use to send to the FHIR server, and go ahead and try it. But wait, we have modifiers for code names also. So the last set of names modifiers that we saw were for strings. These are modifiers for coded values, for code search parameters. So what kind of modifiers do we have here? We have text. This is a really handy one because it will search all of the text fields of a codable concept, including text, display, or identifier text, using this post appended to the search parameter name. Not is the negation. So for example, gender where is not equal to male would match female, other, and unknown. And sometimes this can also come in really handy. It really shortens your URLs sometimes, because you don't have to join statements. Above and below are related. These two only work on code systems that have a tree relationship, so that you know that the system is built like this is a relationship. So you can look at all the data elements, all the coded elements above a certain level or below a certain level. In general, when you're trying to use coded values, You want to go as far out, as they say, as far out on the leaf as possible to be as specific as possible. And sometimes you have to traverse those trees. And so that's what these two particular modifiers are for in the code system. In will go and check for a value set defined by a specific code system. Not in goes and checks if for something that's missing. It's not in, for example, that code is not defined by Loink or SNOMED. And of type is a little bit of a strange one. It's typically used for business identifiers. And you search for the code system where it is of the type. So for example, you want to know whether it's a medical record number business identifier, you want to know if it's a social security business identifier, driver's license. It gives you a way to encode that into the API. So you're looking for the system, and here the system would be driver's license, medical record number, social security number, the coding system as letters, and then the value itself. So here I have that I'm going to go look for FHIR, SUID, social security number of this particular value. All right, quick review. We have names, they have modifiers. Name is equal to a value as our search parameter. They have prefixes. The modifiers come after the name, the prefixes go before the value. Let's talk a little bit more about text modifiers. Let's tell another story. Some systems at my healthcare institution use text descriptions from a drop-down selection. Other systems use code systems such as Loink and SNOMED, but I need to find all of the patients who have reported diabetes, no matter what system was used. So we're trying to cast a broad net. So in that particular case, we're going to say, go to our FHIR server. We're going to look for observations where the code, anywhere in the text of the code, contains the word diabetes. Now, that's a little misleading because it could also potentially, if it's just text, be not diabetes. And so that's a little risky, but just so that you understand, this can still be very useful. Both the display name of the code and the code text are matched. Note, and I have a specific note because I like codes. Note that this query should probably be in addition to a code-specific query. If I were doing this, I would do this, but I would also add an and, or have a separate query, which says that if the code itself was of a Loink code 454841-4, that it would match either. There's other useful modifiers. Missing. Missing works for almost any type of search parameter name, and it will return all instances which do not contain that element. These are real-world tools that we have implemented on systems. You want to look for patients which were entered incorrectly because you want to keep your data clean, because as we discussed earlier, garbage in is garbage out. So one of the things that we're going to do is we're going to go through and we're going to build some scripts, and we're going to look for all records which have the active flag of missing in patient resources. Really, we're going to do this in quite a few different kinds of resources. But here, if we have active missing is true, return all those instances back to the IT manager so that they can go either correct the record or figure out where these invalid records, or at least not great records, are coming from and clean it up. Same as gender. If gender is missing, so gender missing equals true, return all the instances which do not have a gender element. Just so that you know, gender missing can also equal false, or just missing can also equal false. Let's go through another story, one that's more useful for name modifiers. Things can get a little squirrely in ED, that's an understatement. Data entry is sometimes secondary, but accurate data in the server, as we mentioned earlier, is critical. Every morning, the system administrator needs to search the ED database for patients who came in overnight without identification. All right, what ones are we going to search on? We're going to go through and we're going to search for patients where family missing is true. So here's all the patients who don't have a family name. We might want a separate one for given name, missing equals true. Here we have one for gender, missing equals true. Here we have one for address, missing equals true. I can guarantee you there's one for insurance information, missing equals true. But you can see how you can identify the records that need to go back and get cleaned up. And you want to do that usually right away and not let all this build up over time, because the longer that you get away from the incident, the harder it is to clean it up. A summary of the search syntax characters. We have the question mark, which is the search parameter identifier list follows the question mark. And I always read the question mark as where. We have the ampersand symbol, which is an and so you intersect the search results. We haven't had a chance to talk about this, but this is a comma, and this is how you get to ORs, how you OR values. So you get either or for the search values, not the names, but the search values. This is actually a decimal point or a period. And here's how you identify subcomponents of search parameter names, and that'll be in the next video as well. The colon, that's the modifier to each parameter name. We've gone through those. For example, missing. The square brackets mean optional. The pipe means value separator or delimiter. The $sign we'll talk about next, but it's also for separating the values. It's in the next video. Let's talk a bit before we move on about HTTP response codes. We've been talking a lot about the API, but now let's talk about the response codes. So HTTP success codes, a 200, you always want to see a 200. 200 anything, 200 is good. 200 is okay. Remember that if you get an empty search back, it's not an error. It's going to be a success of 200. It's just that nothing matched. So your search was successful, but there just weren't any matches, but it's still a 200. A 201 means that a resource was created. You don't want to see 400s and 500s. Let's talk about errors. A 400 is an API syntax usually. It means that the server cannot interpret your API string, and it's going to tell you you had a bad request. A 401 means unauthorized, and it's a security function. A 403 means it's forbidden. It usually means you may have been able to get into the system, but you don't have authority. 500 means there's an internal server error. Usually if you see a 500, it means that the server timed out and you're asking for too much data and you need to narrow your query so that the server can respond within a reasonable amount of time. So typically a 500 is an internal timeout error on the server and you need to go back and change your query to be more specific. All right, let's recap. Client searches need to be capable of finding a needle in a haystack because these are huge databases. So your API search strings are going to be complex. API syntax is case sensitive. Resources begin with an uppercase in the camel case, beginning with an uppercase letter. And search parameter names are lowercase. And if you do not encode those correctly, you're going to get a 400 error back. FHIR search parameters always have the name of the form of name equals a value. The search parameter names vary by resource. Each resource has its own list of search parameter names at the bottom of the page. The format of the value is identified by the value type, which is also specified on each resource page in the search parameter list. Search parameter names can have modifiers. For example, code text will search for any text within any of the coded values. Search parameter values can have prefixes, for example, greater than 6.4.